All right, let's dive into something that honestly is working behind the scenes all the time, shaping how we see the world, whether it's in economics, biology, even marketing. We're talking about regression, and it's one of the most powerful tools ever invented for finding patterns in what looks like total chaos. So let's get into it and see how this thing actually works.
And it all kicks off with this really simple, kind of strange question. I mean, have you ever thought about this? Why don't the tallest parents have kids who are even taller? If that happened, right, wouldn't we eventually end up with like a world of giants and a world of dwarves? But we don't. So what's going on? It turns out this exact puzzle led to a huge discovery.
Okay, so the guy who figured this all out was Sir Francis Galton, way back in the 19th century. He was studying families and their heights, and he noticed this super consistent pattern. Yeah, sure, tall parents usually had tall kids, but, and this is the key part, their kids' average height was actually closer to the overall population average than their parents' was. He came up with a name for it, regression to mediocrity.
And Galton was just blown away by this. He started seeing it everywhere. The kids of super tall parents tended to, well, regress down towards the average height. And just as weirdly, the kids of super short parents tended to regress up towards that same average. It was like this balancing act of nature, and he was so struck by it, he called it the law of universal regression.
But here's the thing. What started out as this really specific observation about genetics has totally transformed. The modern idea of regression is so much bigger, so much more powerful. It's not just about explaining how we got here. It's become this amazing tool for predicting what's coming next.
So what does that mean today? Well, here's the modern definition. Regression analysis is basically about studying the dependence of one variable on one or more other variables. You've got the thing you want to predict, and then you've got the things you think are influencing it. And what's the goal? The whole point is to estimate or predict the average value of that first variable. And that word average, trust me, it's the key to this whole thing.
And this is where you can really see what we mean by average. Just picture a graph, a scatter plot, with the heights of thousands of fathers and their sons. For any given father's height, you're not going to get just one dot for the son's height, right? You get a whole cloud of possibilities. That's all the natural variability. Now, the regression line, it doesn't try to connect all those messy dots. Nope, it just slices right through the middle of the cloud, connecting the average son's height for each father's height. It's brilliant. It shows us the hidden trend underneath all that noise.
And because it's so good at finding that underlying trend, you see it used in, well, pretty much every field you can think of. Economists, they use it to predict how much we'll spend based on our income. Labor studies, they use it to estimate how wages might change when the unemployment rate goes up or down. Marketers are all over this. They use it to ask, hey, if we spend more on ads, how much will our sales actually go up? It's this universal way of asking, if this thing changes, what can we expect on average to happen to that other thing?
Okay, but here is a super important point we have to make. Regression gives us an incredibly powerful prediction, but it is not a crystal ball. It's not perfect. See, we're dealing with statistical relationships here, and that's a totally different beast than the kinds of perfect fixed relationships you'd find in something like, say, physics.
Let's break that down. Think about a deterministic relationship like Newton's law of gravity. It's exact. You plug in the numbers, you know precisely what's going to happen. But a statistical relationship, not so much. An expert can't predict a farmer's crop yield perfectly just by knowing how much it rained. Why? Because there's always other stuff going on, this random variability that you just can't measure. Regression knows this. It accepts the randomness and just gives us the best possible average prediction in a world that's, a little bit messy and uncertain.
So, to really lock in our understanding of regression, we've got to talk about what it isn't. It gets mixed up all the time with two other big ideas, causation and correlation. So let's clear up that confusion right now. This might be the single most important rule in all of statistics, so listen up. A regression can show a strong relationship, but it can never, by itself, prove that one thing causes another. For example, we can run a regression showing that crop yield depends on rainfall. That makes total sense, right? But the math would also let us run a regression showing that rainfall depends on crop yield, which is just ridiculous. The idea of what causes what has to come from outside the numbers. It comes from scientific theory, or frankly, just common sense.
All right, and that brings us to the other common mix-up, regression versus correlation. Here's the difference in a nutshell. Correlation just measures how strongly two things move together. It's symmetric. The correlation between your math score and your stats score is the same no matter which one you put first. But regression is asymmetric. It has a direction. We are specifically trying to predict the stat score from the math score. So the goals are different. Correlation measures association, regression is all about prediction.
Okay, so we've covered the what and the why of regression. We know what it is and what it isn't. So what's the last piece of the puzzle? What do you actually need to, do it?
The answer, no surprise here, is data. And lots of good data. This can come in a few flavors. You might have time series data, like tracking the unemployment rate every single month for 10 years. Or you could have cross-section data, like a census that grabs a snapshot of millions of people at one exact moment in time. You can even combine them, which is called pooled data. But the bottom line is, the quality of your predictions is only ever as good as the quality of your data.
So there you have it. That's regression. It's this amazing tool that started with a simple question about how tall people are, and it evolved into this method for finding the signal hidden in the noise, for finding that average path through a world that's packed with variables. It helps us make sense of really complex relationships. So that kind of leaves us with one final thought to chew on. What relationship in your world would you want to understand?